Okay, this section is mid-segments. In any triangle, no matter what kind of triangle it is, if you find the midpoint of a side, or of all the sides I should say, everyone remembers what the midpoint is, I hope? Okay?
Yep.
And if you connect them, it forms another triangle in there, like that. Now what this does is, if you connect these two mid-segments, the line that you draw in there is parallel to this line. So what that means is this angle is going to equal that one because they're corresponding.
Okay.
This line will be parallel to that side. So again, these would be equal and these two. And then this would be parallel to these. Put the iPads away. So that's one thing, is that they're parallel. The other thing is this. If you look at, I'll just use this side and this side. As far as their lengths are compared, let's say this whole bottom side was 10 units long. It would be 5. It's half as long, the mid segment. If you cut this out and put it, it'd be there. Okay? So if we extended that and made it double, then they would be the same, 5 and 5 and 10. So if this was 12, this would be 6. If this was 11, this would be 5.5. So that's the whole thing on this section.
That's it?
Yeah. Now, here, we got to go back and we got to use some stuff that we did beginning of the year. We're going to show that the mid segment is parallel. Here's the mid segment. And half as long. So if these two lines are parallel, what do they got to have? Congruent angles, yep. This angle equals that. But if it's on a graph,
Same slope.
Same slope. So you just check. This goes up 1, 2, 3 and over 1, 2, 3, 4. Start down here, go up 1, 2, 3, 1, 2, 3, 4. So both of them have a slope of 3/4. So that shows that they're parallel. Then to show that this is half as long as that, anyone remember what we would have to use to show lengths on a coordinate system?
Is it up here?
Distance formula.
Oh, I hate that.
X minus x squared plus y minus y squared, and you square root it. So here's the x, that's the y, here's the x, that's the y. So 5 take away -3 is 8 squared, plus y minus y. 4 take away -2 is 6 squared, and you square root that. And it is 10. So that's 10. So when we use the distance formula here, we should get 5. They don't have the points in there, but this is 1 over 4 up. And this is left 1, 2, 3, and up 1. So the distance of this, x minus x, 1 take away -3 is 4 squared. 4 take away y is 3 squared. Square root it, and you do get 5. Okay. So here's the theorem that I just told you. The mid segment and the opposite side is parallel and half as long. So in this picture, they're wondering what is PR. PR is this length. How long would that be?
40.
40. Because this mid segment is 20, which means that has to be twice as long, 40. And then ST right there would be 15, because that's 30, so that's 15.
Oh, that's easy.
Yeah. Okay, same thing here. XZ would be double this mid segment, so that'd be 56. And BC would be half of that, so that'd be 14. Okay.
All right.
Now using midpoints, this is the one that's tricky. We got two like this on our assignment today. I think it's two. What they're gonna do is they're gonna give you this little triangle here, and you gotta draw the big triangle around it.
Oh.
So, plot these points. D is 3, 6, 6, 5, and 5, 3. So, it is confusing once you try to do it. So what you got to remember now is this is the mid segment to this side. So whatever goes through this point is going to be twice as long as that and parallel, which means you got to have the same slope. This side right here is going to go through this line. And this side here would go through that line. So it doesn't matter which one you start with. If I do this one here, it's going to go through this line. This goes up 2 and over 1. So you go up 2 and over 1, and there we have half of it. So to get the other half, down 2 and left 1. So there I got a line that's parallel to that, and it's twice as long as it. Now once you get that first one, the other two are easy. Because I know this has got to go from here to here, right? And it's got to be twice as long, down 1 over 3, down 1 over 3. And then once you have that, it just connects like that. Okay? So then they ask, what are the coordinates of the vertices? This one is 2 over 4 up, 8 over 2 up, and 4 over 8 up. One other thing I should point out is the perimeters of these two triangles. How do you think the perimeter of the little triangle compares to the perimeter of the big triangle?
It's twice.
It's, yeah, half as much. Okay, so one more like that. Okay, again, these are the midpoints, so it's 3 over 4 up, 5 over 8 up, and 6 over 4 up. So, you're either going to put a line through this dot, or that dot. It doesn't matter which one you do first. This is going to be the easier one because that's just easier to see. It's got a slope of 0 just straight across, and it's 3 units long. So this one's got to be twice it, 3 each way. Once you have that, you can either do this one or this one, but it's got to connect because that's a midpoint. And then you just continue on the same distance, down 1, 2, 3, 4, and over 1. 1, 2, 3, 4, and over 1. Be right there. And then once you have that, there. So the first line is the tough one. Once you get the first one in, then it's not so, then it's pretty easy.
Sweet. It's very good.
Okay, so the one I just told you now is the perimeter of this big triangle is 10, 11, and 7 is 28. So the perimeter of the little one is just half, 14. And if you forgot that, you could check it, because if this is 10, this is 5. If this is 11, this is 5.5. And if this is 7, that's half, 3.5. If you add those up, they add up to 14.